So today we are starting chapter 4. This is 4.1 angles and their measure. And before we get to our title slide, I want you to look at the problem here, our bell ringer problem, and see if you can figure out what this is. So go ahead and pause the video, read the problem, see if you can figure it out, and then hit play. Alright, so I'm trying to draw our pizza. Okay, so we have a large Papa John's Supreme Pizza. I've changed the wording on this several times over the years because students are always asking more specifics, so that's why it seems very oddly specific, way more so than needed. So when the person cuts your pizza, they start off by cutting it in half, then they cut it in half the other way, and then they cut each one of those pieces in half, and then they cut each one of those pieces in half. And ultimately you end up on a large Papa John's, or large pizza for most people. You end up with 8 total pieces. Okay. Now, assuming that they are all cut the same size, which of course they're not, if they're all cut exactly the same size, then I say, well, there's 360 degrees total in a circle. If I divide that by 8, I end up with 45 degrees is a single slice of pizza. So because of that, you could say that for any large pizza, assuming there are 8 pieces, the average degree, the average angle is going to be 45 degrees, even if they're not all cut the same, because they gotta all still average out to be 45. Okay. So today we're talking about different kinds of angles. So we're doing 4.1 angles and their measures. Okay. Let's think about this, because we're going to talk about something that you've used a lot but probably never really thought much about, and that's the assumption we actually made on our last problem. So I have a circle, and people have had circles, and they wanted to measure the degrees of circles. So let's think about, go back before you learned anything about degrees. You have a circle, and you want to measure an angle from here to there. Okay? Degrees hasn't been invented yet. There is no such thing as degrees. You are in charge of coming up with a way of measuring that, as opposed to say that. You want to say, okay, this is smaller than that one. The length of the lines doesn't matter. You have to come up with a way of measuring those two angles and being able to tell them apart. All right. You know you want to do this in a way that is precise, so you want to be able to measure very, very small angles, okay, but also, of course, very big angles. You had this idea of a circle because you know if you start here and you go all the way around, you just get back to the beginning. Well, what value do you use? All right, now you understand on the back side of this that we use 360 degrees as a circle. So we have 360 degrees. But why? I mean, 360 is kind of a random number. It's not a 100. It's not a, it doesn't have much meaning. It's close to the number of days we have in a year, but that's 365, so it's even short of that. Well, as it turns out, 360 actually is very random. In fact, it doesn't have any specific reason for why we choose 360 other than the fact that 360 can be divided by a lot of different numbers. It's easily divisible by a lot of different numbers, and so that makes it easy to divide a circle into different parts. So we can divide it by 8 or 12 or 6 or whatever. It divides very well. It's a large number, so I can divide my circle into a lot of parts, 360. But we use 360 just because it can be divided into a lot of parts. So someone decided 360 was enough degrees because it's divided into a lot of numbers and it's large enough to do degrees. They could have easily picked a number larger or smaller, but chose not to. They chose to use 360 degrees. So arbitrarily they picked it, and we have used it ever since. Well, we're actually going to talk about two different ways of measuring angles. So we use this is degrees, okay? But just like there's such a thing as feet or meters, okay, so just like we can measure things in feet or meters or say miles or kilometers, okay, we have our English system, measure system. Well, there's two different ways we can measure angles. We can measure them in degrees, or we can measure them in radians, okay? So let's think about what that looks like. So again, I have a circle, and we would say that if I went here, that is 180 degrees, okay? Or I could say that it is 1 pi radians, okay? So halfway around the circle is 180 degrees, or 1 pi radians. If I go all the way around my circle, that's 360 degrees, or 2 pi radians. All right. Let's say I only go 1/4 of the way around my circle. Okay, so I just go 1/4 of the way. Well, that would be 90 degrees, or, well, it would be half. If 180 degrees is 1 pi, it would be half of that, or just half of pi, pi over 2 radians, which sometimes we'll shorten to RAD. All right, so pi over 2. And I could keep dividing this up. I could say, well, what about this? I meant to use a different color there. Let's try that again. What about this? Well, this would be 45 degrees. Well, it's half of a half, so, or 1/4 of a pi, so pi over 4 radians, okay? So, two different ways we break up a circle. All right. Now, we're going to use that in just a second, but I'm actually going to backtrack just a bit to using just degrees and a different system. So, if I pull up my thing right there we go. We have this thing called DMS, okay? And oops, I need to be right on it. DMS stands for degree, minute, second. Yeah, so degree, minute, seconds. The probably easiest way to think about it is, instead of degree, minute, seconds, hour, minutes, seconds, because it works just like a clock, okay? And so the problem is that sometimes I have an angle and it's not exactly 30 or 31, it's in between 30 and 31, somewhere in here, okay? Well, I could just make it a decimal. I could make it 30.23 or something like that. Or we could use this form. All right, this is a very common form to use. Get rid of this. Why is that on my screen? Okay. So let's see how this works. We're going to change from degrees, minutes, seconds to decimal form. All right. And so what we're going to do is we're going to say, well, this is our seconds. We want to change from seconds to minutes. So I'm going to say, well, how many seconds are in a minute? Well, there are 60 seconds in a minute, so I'm going to divide 36 by 60. Okay. If I get my calculator out, 36 divided by 60, I get 0.6. Okay, so what that means is this is 42 degrees and 24.6 minutes. Okay, well, I want to change from degrees and minutes to just degrees or just hours. Well, think about it. There are 60 minutes in an hour, so I'm going to say 24.6 divided by 60. 24.6 divided by 60 is 0.41. So I end up with 42, and then the decimal is 0.41 degrees. Okay, so that's how I change from degrees, minutes, seconds to just a decimal degree. All right, go ahead and try number 2. Move that out of the way. So for this one, you don't have any seconds, which is okay, so you're just going to divide the minutes. So go ahead and pause the video, try it, and I'll put the answer on the board. Okay, so you should have done 12 divided by 60 and got 0.2, so your answer is 23.2. Alright, well, what if I have the decimal degree but want to go in degrees, minutes, seconds form? So let's see how we do that. Well, I know I'm going to have 37 degrees, something minutes, and then probably something seconds. I know 37 degrees because there it is right there. So I'm just trying to get rid of the decimal. So I'm going to take my decimal, which is 0.425. Now, I got this decimal from going from degrees to minutes seconds by dividing by 60. So to get rid of it, I want to multiply by 60. Okay, so I'm going to say 0.425 times 60, and that gives me 25.5. So my 25 is going to go there. There's my minutes. But I still have that 0.4 left over. I will take that 0.4 and say 0.4. So now I have 0.4 minutes. Well, how many seconds is 0.4 minutes? Well, I just multiply it by 60, 0.4. And actually, you may be, if you're doing this along with me, you might be yelling at me because I actually wrote that down wrong, didn't I? Sorry, that's supposed to be a 0.5. My apologies. I wrote it down, oops, correct right there, and then did it, so I just erased it. So that was supposed to be a 25.5. I've already erased everything though. Sorry, I hit the eraser when I thought I had pens. Let me go back and fix that. Alright, so we had 0.425 times 60, and that should have given me 25.5, not 0.4. Okay, so the 25 went there. That 0.5 right there comes down here. So I have 0.5, not 0.4. 0.5 times 60. Well, 0.5 times 60 is just half of 60. So 0.5 times 60 should give me 30. 30 goes up there. Sorry for that confusion. Okay, so I changed from decimals to degrees, minutes, and seconds. Okay, go ahead and try number 4. I'm going to go ahead and pause the video and give it a shot. Okay, so you should have taken the 21 and said, okay, well, my answer is going to be 21 degrees, and then some kind of minutes, and then maybe some kind of seconds. We only got 0.2, so we're probably not going to have seconds on this one. So we're going to take that 0.2 and say 0.2 times 60. Well, 0.2 times 60 is 12. That goes here. And there is no decimal, it's just 12. So my answer is 21 degrees, 12 minutes. Okay? And so that's another way of using degrees. Now that's not two different forms of measurements, that's still degrees, so it's not like going from degrees to radians. This is still degrees, it's still the same thing, it's just two different ways of writing the same thing. Okay, so it's still using degrees, it's just a different way of writing decimal degrees. All right. Well, what if we have degrees, and I think there's 4 of these, yep. Let's say I have an angle that's in degrees, and I want to change it to radians. Well, we did a couple of these. We said that 180 is 1 pi radian, 360 is 2 pi, we did 90 degrees is pi divided by 2, and we did 45 degrees is pi divided by 4. But what about all these other ones? How do I change those? Well, we need a conversion factor. So for instance, let's say I had 3 feet, and I said, I want you to tell me what is 3 feet in inches. Okay, well, you'd probably just multiply it by 12, but what you're really doing is saying there are 12 inches in 1 foot. All right, I have a conversion factor here. 12 inches is equal to 1 foot. So when I multiply by 12 inches and over 1 foot, they're the same. And when I multiply something over itself, it's just 1. Okay, well, here the feet cancel out. 3 times 12 is 36, and of course divided by 1, 36 divided by 1 is 36. So that's how I would really convert. So we're going to have a conversion factor for r. We have degrees, we want to change to radians, so I'm going to say, oops, let's do a different color. I know that 1 pi radians is the same as 180 degrees. Okay? So they're the same, so this is the conversion factor we're going to use. And I'm going to multiply. When I multiply, my degrees cancel out. I get 1 pi times 225, which is just 225 pi over 180, and I still have my answer in radians. Alright, so that's my answer, but that's not very simplified. Let's see if we can simplify it. So I'll go ahead and tell you there's 2 ways. One, you can just see what divides into 225 and 180. Okay, you could divide by 2, you could divide by 5, whatever. The other thing is I could just type in my little box over box in my calculator. If you want to be faster about this, put in 225 over 180, and it'll simplify it for you. Don't put pi in it, it doesn't know what to do with the pi. We're just going to tack the pi in. So that simplifies to 5 over 4. So my answer is going to be 5 pi over 4 radians. And I'm just going to shorten radians to RAD. Okay. We'll do one more like that. I'll try number 6, 320. Okay. So again, multiply by 1 pi over 1 pi radians over 180. The degrees cancel out. 320 times 1 pi is 320 pi over 180. radians. Maybe you like to do these by hand. I'll actually do this one by hand instead of using the calculator. I'm going to divide them both by 10, which means I end up with just 32 over 18. And let's just divide them by 2. 16 over 9, and 9 is only divisible by 3. 16 is not divisible by 3, so I'm going to say that's as far as I can go. Make sure I tack on my pi in the top. 16 pi over 9 radians. Okay, go ahead and try 7 and 8. Pause the video, and then I'll give you the answers. Alright, so for 7 and 8, and the ones we just did, those are your answers. Alright. Let's try number 9 together. Alright, so for number 9, we're trying to go backwards. I have 3 pi over 4, so I'm in radians already. I want to go to degrees. So I'm going to use the same conversion factor, but I'm going to flip it. I'm going to put 180 degrees on top because that's the units I want. I'm going to put 1 pi radians in the bottom because that's what I'm trying to cancel out. Okay? So the word radian isn't going to cancel out, but the pi will. Alright, so that pi will cancel out. Okay, so I end up with 3 times 180. 3 times 180 is 540 divided by 4. Well, 540 divided by 4 is 135 degrees. Okay, we'll try one more together. Again, multiply by 180 degrees over 1 pi radians. Okay, well, the pi cancels out, the pi radians cancel out. Multiply the top, 7 times 180, 1,260 degrees divided by 4 times 1 is 4. Well, divide that by 4, and I get 315 degrees. Okay, try number 11 and 12. Alright, the answers to number 11 and 12 are 250 degrees, and number 12 is 60 degrees. Oops. Alright. Let's switch to circular arc length. Okay, so what it's saying is that we have some circle. There's our circle. We have some angle right here, and this little symbol right here is called a theta. You'll see it on our Greek alphabet board. Whenever we see that, it always refers to an angle. So it's kind of like x, except it specifically tells us that it's talking about an angle. So it tells me an angle. R tells me the radius. Well, the radius is the length from here to here, and also from here to here. Those are both R. And then S, which is what we're trying to find, is the length from here to there. So it's called an arc length. It's the distance, oh my goodness, what was that? From here to there. Okay, so it's just on that arc. So it's kind of like perimeter, except, it's kind of like circumference, only it's just part of the circle. Okay, so we're going to try a couple of problems like that. So my formula is, if I go back to it, actually let's go ahead and put all these up here. Make them a little smaller. There we go. Now, what is important, you may have noticed, guys breezed over it too quick, is my angle has to be in radians for my formula to work. So for instance, on number 16, we're going to need to change our formula to be radians before we can do it, okay? Now, maybe you're looking at your formula, which is very simple. It's S equals theta times radius. And you're like, I'm pretty sure I can do this by myself. Awesome. Go ahead and pause the video now, go ahead and try them, and then you can check as I go and see if you did it right, okay? So I'm just going to work through each one of these problems. Definitely encourage you to try them before I work through them and see how you're doing, okay? Well, here we go. So S equals pi times the radius. Well, my pi is, my angle is 25 radians. My R is 2. 25 times 2, 50. And remember that I'm in length, so since this is in inches, this needs to be in inches. Come over here to this one, and I have S equals theta times R. Well, this time I know S is 1.5. I know my theta is pi over 4. I don't know what R is. I want to get rid of that fraction, so we're going to multiply by its reciprocal, 4 over pi. Not 4 over 5, 4 over pi. And I'll grab my calculator and see what it says. So 4 times 1.5 divided by pi, and I end up with 1.9, around the 2 decimal places. 1.91 is my R, and I do want to remember that since S is in feet, that's 1.9 feet. Okay. Moving on down here, I have S equals theta times R. My S is 3. I don't know theta. My R is 1. Divide both sides by 1, and I get my theta is 3, and then my units is radians. 3 radians. Alright. Number 16, I need to change my angle from degrees to radians. So I need to multiply by pi, or 1 pi, over 180. Well, 20 times 1 is 20, divided by, 20 over 180. Simplifies to 1 over 9, so pi over 9, or 1 pi over 9. So S equals theta R. My S is 40 equals pi over 9 times R. 9 over pi, 9 over pi. So I end up with 40 times 9 divided by pi, which is 1145.9, sorry, 144.59 equals my R. And remember, my units of S was centimeters, so my units of R is also centimeters. Alright, last one we're going to look at. Definitely want you to try this one before I do it. So go ahead and try this one, pause the video, and then I'm going to go over it. Alright, so we're asking for perimeter. So I'm going to draw a picture of what we have. We have 11 is our radius, so both of those sides is 11. This side is S, don't know that one yet, and this angle is 10 degrees. So Let's start off by changing 10 degrees to radians. So pi over 180. Well, if I have 10 pi over 180, that's just 1 pi over 18. Don't know what S is. My angle is pi over 18. My R is 11. Multiply those together. We have pi divided by 18 times 11. S is 1.92, around the 92. Okay. Okay. And of course that's in inches. Now it asks for perimeter. Okay, it didn't ask for my arc length. Perimeter is all the way around. So to find perimeter, I need to say, well, this side is 11, another side is 11, and then the last one is 1.92. And then add all those together. And I end up with 23.92 inches is our perimeter. And that's the last problem. So good luck on homework, and I'll hopefully see y'all tomorrow.